Hello students, today we'll be solving some numerical on stresses in composite section. If a section is made up of two or more different materials, so it is called as your composite section. If a composite section will be subjected to an axial pull or force, then it will be contract or expand as a unit. What are the points to consider to find out the stresses in composite section? So this is one composite section consisting of material 1 and 2. So for that, first point is the extension and the contraction of the section of different sections of each material is considered as the same. If the contraction and expansion are same, then the strain produced by each section will also be equal. Deflection of material 1 will be equal to deflection at material 2. So deflection is nothing but PL by A. So for section 1, it will be P1. Length being same, we'll keep it as L. Then A1, E1 will be equal to P2 L divided by A2, E2. So by cancelling the L, we'll get P1 divided by A1, E1 is equal to P2 divided by A2, E2. P by A here is nothing but sigma, that is stress. So stress of material 1 divided by Young's modulus is equal to stress of material 2 divided by its Young's modulus. Okay, so then the next point is the total external load is the sum of load carried out by each material. So here it is two material. So the total load will be equal to load of material 1 plus load of material 2. So load is nothing but stress into area. Okay, so stress of material 1 into area of material 1 plus stress of material 2 into area of material 2. Okay, this will be equal to the total load. Okay, then let's solve some numerical on it. A concrete column of 350 mm diameter is reinforced with 4 bar of 25 mm diameter. Find the stress in steel when the concrete is subjected to a stress of 4.5 megapascal. Also, you have to find out the safe load for the column. So you have to take Young's modulus of steel to Young's modulus of concrete is 8. It is called as your modular ratio of steel to concrete. So it is given as 18. Okay. So according to the given data, diameter of the concrete column is given as 350 mm. Diameter of the steel rods given as the 25 mm. And the stress on the concrete is 4.5 megapascal. So it is nothing but 4.5 Newton per mm square. Then modular ratio is given as 18. Then area, then we have to find out the area of the concrete column. So area is nothing but pi by 4 d square. Pi by 4 here diameter is the 350 mm. Pi by 4 d square we are getting this value. Then area of the steel rod is here we have 4 steel rods, 4 bars. So 4 into pi by 4 d square. So 4 into pi by 4 into 25 square. So we are getting the area for the all 4 steel rods. Okay. Then the area of the concrete is, it is the area of the total concrete column minus the area of the steel rods. So area of the total concrete column is this minus area of the steel rod is this. So for stresses in composite section, we know that sigma S by ES is equal to sigma C by EC. Okay, so from that formula, we can get sigma S is equal to Young's modulus of steel to the Young's modulus of concrete multiplied by stress of concrete. Okay, this is given as modular ratio, it is 18, and stress of concrete is given as 4.5. So by putting this value, we are getting it as 81 megapascal of stress of steel. For the safe load calculation or total load calculation, we know the formula is P is equal to sigma S AS plus sigma C AC. That means load, that is the summation of load of each material. Okay. So here we have two materials. One is steel and another is concrete. So for steel, the load will be sigma S multiplied by AS, and for concrete, the load will be sigma C multiplied by AC. By putting the value, we are getting it as the total load or safe load will be equal to 583158.6 Newton. To the next question, a reinforced concrete circular section 50,000 mm square cross section. It carries 6 bars whose total cross-sectional area is 500 mm square. You have to find out the safe load for the column if the concrete is not to be stressed more than 3.5 megapascal. Modular ratio for steel and concrete is given as 18. Okay. According to the given data, we have area of the concrete circular section, that is total area, that is 50,000 mm square. Area of the reinforcing bars, that means all 6 bars together they are 500 mm square. Number of bars is here 6, and the stress on concrete is 3.5 megapascal, that is nothing but 3.5 Newton per mm square. Modular ratio is given as 18. Then area of the concrete will be total area minus the area of the steel bars. That means it will be equal to 49,500 mm square. Here we have to find out the safe load. Then the total load will be equal to the load carried out by the steel and the load carried out by the concrete. That means load by steel plus load by concrete. That is nothing but sigma S AS plus sigma C S. Here we know that for the composite section, the strain for each material is equal. So that is if the strain will be equal, then the formula will be sigma S by ES. That is nothing but strain at steel, and here the strain for the concrete. So sigma S by ES is equal to sigma C by EC. Okay. Here we know the value of sigma C, it is given, and ES by EC, that is modular ratio for steel and column, that is given. So here we can easily find out the sigma S value. Sigma S value will be equal to ES by EC is given as 18 and sigma C is given as 3.5. So it will be equal to 63 Newton per mm square. Now put it in the formula. The total load will be sigma S, we are getting it as 63. Area of steel is 500 plus sigma C is 3.5. It is given in the question. And SC is 49,500. This is the area of only concrete, not the steel. So by calculating, we are getting the safe load as 204750 Newton.